Thank you, Stephanie, for that introduction. And it's really a pleasure to be here. Can you hear me in the back? Yeah? Okay, cool. Yeah, so I'm going to be talking about the role of the body in structuring sociophonetic variation. This is a really new phase of my research, but it represents my next phase. So I'm really excited to be able to talk about it. It's also the first time I've been able to talk to a group of cognitive scientists. So I'm very excited to get your feedback on where this is going. Okay. So scholars of gesture and bodily access have long recognized that the body plays a central role in speech production, right? So we know, for example, that when people talk on the telephone, even though their interlocutor can't see them, they still produce gestures. There's a connection there then between speech production and the way we move our bodies. But variationists, people who study sociolinguistic variation, have constructed their theories of variation and sound change completely on the basis of what can be observed in the audio channel alone. And I think we're missing out on something by doing that. So this paper draws on a multimodal analysis of audiovisual data to show that voice quality and vowel quality strongly correlate with how the body is used and the facial expressions that we make. Okay. I think this is going to have some implications for sound change, so I'll talk about those toward the end of the talk. All right, so there is this connection between the body and language variation. Not many studies have looked at it. Here are 4 of the maybe only studies that have looked at it. I'll just talk about the first one here. Norma Mendoza-Denton and Stephanie Janity looked at one woman talking at a town hall meeting for a politician. And they looked at about 3 minutes of speech, and her speech was an impassioned plea. Very large gestures she was making. And what they found was that her pitch accents tended to coincide with the gestural apices. So when gestures reach their points of maximum displacement, that's when speakers were producing pitch accents. So again, there's this connection between the body and the language we're producing. Yet we haven't really looked at this. One of the reasons is because examining this connection, there are 2 main hurdles to examining this connection. One is the large-scale analysis of body movement, right? So that Mendoza-Denton and Janity paper that I discussed was based on about 3 minutes of data. The amount of coding that they had to do to analyze that 3 minutes of data was astronomical, right? This was manual annotation, not something that you could do on data sets the size that sociolinguists are accustomed to working with, right? So we would look at, at least, 20 to 30 speakers, sometimes many more than that, and maybe an hour worth of speech per speaker. We're not going to be able to do large-scale gestural analysis. But recent advances in computer vision have really, I think, expanded the types of analyses that we can do, and I think it's time to incorporate those into the study of variation. Another hurdle has been the collection of high-quality audiovisual recordings, ideally in a relaxed environment. Okay? So if I put on my phonetician hat, I want really good audio quality so that I can do sensitive acoustic analysis. To get that really good audio quality, typically I'm going to bring a speaker into a soundproof recording booth. That's great for audio quality, not so great for naturalistic social interaction. When people are in a very institutional setting like a sound booth, then they don't tend to relax into the environment and produce their most unguarded forms of speech. What we tend to do to get that type of speech is collect data out in the field. Of course, that doesn't result in very good audio quality. Then we can add the whole issue of getting video data on top of that to this. The way we've, in my lab, have dealt with this is to collect an audiovisual corpus of friendly interactions in what we call the living room. I'll talk a little bit more about that in a bit. So in this paper, I'm going to talk about data that we've collected in the lab, and I'm going to be focusing on 2 linguistic variables, voice quality and vowel quality. Okay? Both of these correlate with body movement and facial expression. Well, why should we care that there's a connection between body movement and variation? Like, so far I've just given you examples that establish that there is a connection, but why do we care about it? My main argument is that the body is a window into affect, right? And that we need to attend to affect as a way of enriching our social analyses of linguistic variation. Right now, we correlate linguistic behavior with social categories that characterize speakers. Things like their sex categories, their ages, maybe their ethnicity, but this offers just a partial analysis, right? The two forms of embodiment that I'm going to be talking about, I think, enrich the analysis by bringing some affect into the equation. So body movement and smiling are the things I want to talk about. So there's some very old work here that I'm listing here, but I think this work, these classic studies show that there's a connection. So in Dittman et al., dancers and psychotherapists both were able to infer affective information from the way that speakers were moving their bodies, okay, when they just saw movement. Dancers were a little bit better at it than psychotherapists, it turns out. And then in another study, it was shown that body movement conveys information about the intensity of emotion. So body movement and arousal, there's a tight connection between that. Perhaps less controversial is that there's a connection between affect and smiling. Okay, in some classic work there by Ackman et al. Subjects watched a video and then they reported on their emotional states later, and their facial expressions were measured in videos of them watching the videos. So people who were smiling more, or people who smiled were more likely to have reported being happy, and the intensity of their happiness correlated with how big their smiles were. Okay, so there's a connection between at least these two forms of embodiment and affect. Now, for my purposes today, the precise value of the affect conveyed by body movement and smiling is less important than the fact that both forms of embodiment communicate affect, which I hope is uncontroversial. All right, so an overview of what I want to do. Again, I'm pretty excited about the space that we're collecting the data in, so I'll spend a little bit of time talking about that, as well as our methods for analyzing body movement and facial expression. And then, as I mentioned earlier, I'll talk about the results for two linguistic variables. First, creaky voice, or creaky voice. It's hard for me to project while I'm doing creaky voice, but this has probably surpassed the discourse marker like as the most discussed sociolinguistic feature in media. I'll also talk about the front lax vowels. These vowels are lowering and backing in the California vowel shift. If you don't know what the front lax vowels are, we'll talk about that in a second. Okay. But for both of these features, I'll review some previous proposals in the literature that are based on ethnographic work as well as discourse analysis that suggest that these features convey affective meaning. Right? And the work that I'll be presenting is quantitative, and it doesn't look at discourse analysis or ethnographic methods. It uses visual analysis to draw really a lot of the same claims, but using a completely different approach. Okay? So treating the body as a window into affect has implications for both the quantitative analysis of variation as well as theories of variation, and I'll talk about both of those. Before I really get into describing my methods, I need to acknowledge these three people, my primary collaborators on this work. So Patrick Collier, who I think came here last year to talk about some of his work with Twitter, is that right? Was a former postdoc in the lab. Rob Voigt is a second-year graduate student in the linguistics department who I think considers himself a computational sociolinguist. There is such a thing now. And Catherine Hilton is a fourth-year graduate student in the linguistics department at Stanford. She has a background in discourse analysis, so we're really looking at all of these phenomena from a variety of perspectives, from the highly quantitative to the very local qualitative approach. All right, so here is a picture of the living room, the Interactional Sociophonetics Laboratory. It has the acoustical specifications of a sound booth, but it's staged like a living room. So if you look here, the walls look like they might be wallpaper, but if you actually get up to them and touch them, they're actually acoustical panels. There are lots of soft furnishings in the lab, so the The acoustical engineer that was helping in the planning of the lab said we really should have a shag rug that appealed to my design sensibilities, so we were glad to accommodate the acoustical engineer with that. And it's staged as a living room. So the idea is that people can relax into this environment and hopefully produce speech that's a little less self-conscious than the type of speech that might be produced in a typical sound booth. It's also bigger than a typical sound booth. Some people feel a little claustrophobic. What are the things I want to draw your attention to? You can see that there's this decorative box in the bookshelf here. You might recognize it from IKEA. The hole in that decorative box, just behind that hole is the lens of a camera. That camera is capturing the speaker who sits here. Okay. There's another decorative box here, which is aimed at the speaker who would be sitting here. So we're recording people in dyads, and they're sitting opposite one another in the living room. The reason why we need to get this head-on shot of each of the speakers is that many of the computer vision methods that we use assume that. A lot of these methods are designed for speakers that are vloggers, okay? And so this is our way of trying to approximate that shot. It turns out the methods work reasonably well. People who do interactional analysis would never analyze a video that doesn't have all of the interactors in it. So we have another video camera. We drill a hole in the clock, and we put a USB camera in there. That's aimed at both speakers, so we have one shot that captures both people in case we want to do that type of analysis. So we wouldn't use that for the quantitative analysis, but it might be useful for the more qualitative approach. Anything else that I want to draw your attention to? Yes, this binder here, it's like a Rolodex, is where we put the prompts. We give speakers prompts that they can discuss during the recordings. We spent a lot of time talking about what the most effective way to present these prompts would be. We thought about displaying it on the TV there, but then we didn't want one of the speakers to have to constantly turn down or turn around to see the prompt. We also didn't want to control the prompts that they were using. We wanted them to be able to choose whatever prompts they wanted to discuss. We also didn't want to give them a piece of paper, right? Because if they're using the piece of paper, they're going to be engaging with that paper. It's going to create some noise. It's also going to constrain their body movements in a way that they wouldn't be constrained if the paper didn't exist. So we have them engaging with this Rolodex, which each of them has a different question. I'll talk about the types of questions that we put on them later. Okay. So when we recorded people in dyads, this is an example of the views that we get. So here are two people talking with one another. I chose the screen captures strategically, so she's supposed to be kind of smiling and she's using her hands a lot. For each speaker, we have two recordings, an audio recording and a video recording. Coordination of these four separate files is a bit of a challenge, but that's something that we've dealt with. Ideally, each of the speakers that we bring into the lab are going to come in twice. Once they'll bring a friend to talk with, and then another time we'll set them up with a stranger to have another interaction with, just to get a range of interaction types for each person. Obviously, participants are aware that they're being recorded. We outfit them with wireless microphones that they wear during the interaction. A lot of times, the interactants are trying to guess where the cameras are, and often they decide that they know exactly where the camera is, and it's not actually the place where the camera is. Sometimes they see it, but even when they know where the camera is, after a little while, they relax into the environment. Often we'll talk about quite personal matters during the recording. So I think that they're not being they're not centering themselves too much by knowing that the camera's there. At first, we ask them to answer some would you rather questions. So we first have a Rolodex in there that has would you rather questions. What would an example be? Would you rather always be on time or always be late? Right? And then they have to talk about this question. These questions are just there to break the ice, especially for these stranger interactions. It's one way to do that. We also check the audio recording levels during this time so we can make adjustments and make sure that we're getting the best data that we can. Then they engage in about 30 minutes of conversation. And they have prompts, again, as I mentioned before, to facilitate this. They never have to stick to the prompts when they're answering these, when they're having these discussions, but they're there just in case they need them. We decided to choose prompts that encourage the reflection on identity construction without explicitly asking about identity construction. So, and I think this is what differentiates this corpus from many others. So one example would be, how has the way that you dress changed since high school? Okay, it's hard for people to answer that question without talking about how maybe their style of dress reflects their level of professionalization, maybe their gender identity, for example, but we're not saying, please reflect explicitly on your gender identity. So that's how we're getting them to do that. Following the recording, we get our participants to answer a pretty lengthy survey. In the survey, we're collecting a lot of demographic information, right? So some of this is things like, where are your parents from? As sociolinguists and dialectologists, we need to know about what kind of language input they had. We want to know all the places they've lived and how long. And in addition to this demographic information, we get them to assess how the interaction went. So in their view, how comfortable was it? How good a listener was the person that they were talking with? How much did they click? Okay. So it's a rather lengthy survey. I just want to play an example of some of the data. Remember, we make two different video recordings, two different audio recordings. We put them together for this. It's not particularly interesting. I just grabbed a random bit from one of them. Hopefully the sound will be
Think like, I'm going to change my style now.
Or just like getting some new clothes.
Yeah.
That wardrobe.
Yeah, you know, for sure.
Effect on how people saw me. So I remember this time in college when people started saying, we're like, I think it was over spring break or something, and I broke up with my boyfriend, and I decided that I needed new clothes, and so then I came back and I oh, it's Natasha.
Yeah.
I mean, the biggest thing is that when I was really little, I was really dresses and so that lasted until like age like 4 or something.
Yeah. Oh.
Like, got it off.
I don't know if you heard what she said there. She's talking about wearing pink frilly dresses when she was little. So this is an example of how the people talking about the way that they dress will bring up gender identity, as well as you can infer her stance toward having worn these pink frilly dresses when she was little. That's not going to be relevant to any of the things that I'm talking about today, but I think it's relevant for things that we can do with the data later. Okay. Hopefully you also heard a lot of creaky voice in her speech. Okay. Moving on. The sample of speakers that I'll talk about today consists of 35 speakers. It's about 18 hours of recordings. Most of these people are close friends. Okay, all of these recordings are from interactions between familiars. We're now collecting data with strangers, and we hope to increase the size of that sample later. So again, we're focusing on 35 speakers now. We've done recordings with about 120 speakers. The reason I'm not talking about all of them is because they haven't all been transcribed. That's really the bottleneck in this analysis, is getting the data transcribed, because we need that to do any of the acoustic analyses. About 2/3 of the speakers are women, and the great majority of them are undergraduates at Stanford. In future recruiting efforts, we'll make an effort to get a more diverse sample in terms of the age as well as the class backgrounds, right? This skews toward middle class speakers. We hope to change that in the future. About half of the speakers are white, the other half identify as some other group, many of whom are multiracial. One of the things we'll want to do in future analyses is figure out how to deal with the multiracial category. A lot of times in sociolinguistic studies, what happens is speakers who identify as more than one race or ethnic group get removed from the sample, and we think that that is there's a real danger in that. So we wanted to make sure that we included speakers of a variety of ethnic backgrounds. Many of these speakers, 19 of them are from the West, most of those are from California. We've got some people from other areas as well. Okay, so that's a bit of background about the sample that's in the data set for this study. For the acoustic analysis, as I mentioned, transcription is the bottleneck in our analysis process. We get all of our data orthographically transcribed. We need those. They're time-aligned orthographic transcriptions because we then use speech recognition technology to get forced alignments. Okay. I've worked with forced alignments with using a lot of different types of data, so mostly sociolinguistic interviews, and they do pretty well, but not great with those. With these lab data, I'm really shocked at how clean the alignments are. I think part of that is because they're very good audio quality. I trust the automatic acoustic analyses from this data set much more than I would for sociolinguistic interviews. All right, for every vowel interval in the result of the forced recognition, we measure a number of acoustic measures every 10 milliseconds, and then we reduce each set of measurements for a given vowel to the median value. So that's going to deal with some of the errors as well, right, by taking median values there. Okay, then we did not manually annotate whether each vowel was creaky. We used a neural network classifier. So Kane et al. Published a paper in 2013. They have a method that takes in a lot of different acoustic measures, and they trained a model that would be able to identify whether it's creaky or not. It works at about 80% accuracy, which is pretty good. I think human coders are behaving at about that same rate. And of course, the really nice thing about this is that we don't have to touch the data at all. Okay. All right. So next, I want to talk about the methods that we used for quantifying embodiment, forms of embodiment. The first one is movement amplitude, and the basic idea behind this is that a video is going to be a series of static frames, right? And so you can compare one frame to the next in a video, and any changes in pixel value are going to be indicative of spots where there was movement, right? So we could take a video like this. I'm just going to play it.
Like what happened the rest of the day, I guess.
These aren't data from the lab, but they're the data that the method was developed on. We could then develop this this video transform that shows the things that are moving. Okay, so you see the hand movements there. Okay. And then if we count up the number of pixels that are activated at any given frame, we get something like a waveform representation, and we can use that to correlate the use of linguistic features with that. Okay. So that's our method for looking at movement amplitude. In other work, we've found that there's a strong correlation between movement amplitude and F0, right? So people tend to produce a higher F0 when they're moving more. I think this probably coincides with your intuitions. We also used a method for smile detection. So there's an open source data set of photographs that are just coded for whether or not the speaker is smiling. And we used that to train a classifier. And then we ran every frame of the video through that classifier to identify points in time when people are smiling. So the way that that works is it uses facial recognition technology. Within the face, it finds a mouth, and then whenever you see green or moments of time when it's saying that the speaker is smiling. Okay. So that's how we dealt with smile detection. Our statistical models. So one thing I should mention: every observation in the studies that I'll be talking about, every observation is a vowel segment. Okay. So was a vowel creaky, right? For each vowel segment, what was the median F1? What was the median F2? Okay. We included a number of random intercepts, a number of linguistic and social predictors, and these linguistic and social predictors are what I would call like well-established predictors. Other social predictors that we included were the two that I just mentioned, these forms of embodiment, movement, amplitude, and smiling. And then we also looked at some interactional predictors. Remember, after every interaction, speakers had to rate the interaction in terms of how comfortable they felt, how good a listener the speaker was, etc. So we looked at the influence of some of those. Okay, let's begin with creaky voice, which I really just produced. When you work on Creek, you start to notice all of the times when you use it. What I want to do for each of the two sets of linguistic features that I'm talking about is review some previous work on the feature, just to give you a backdrop against which to analyze the results from the lab data. And the previous work that I talk about is going to be based on what we found in the Voices of California project that Stephanie mentioned earlier. So far, we've collected data in 4 field sites of California, all in the Central Valley. So Merced was the first community that we visited. We also went to Redding the next year, Bakersfield the year after that, and then last year we went to Sacramento. For Creaky Voice, I'm going to be talking about the data from Redding, Merced, and Bakersfield. Okay. This analysis is based on on 93 speakers. These were all white speakers in the area. White is the only ethnic group that is represented in well represented in all 3 of these field sites. Okay. So what did we find? Well, first of all, there was a strong effect of sex. Women exhibit stronger, more common creak than men. Okay. So this, to some extent, I don't want to say validates, but maybe provides a context for understanding why the media has been latching onto young women as users of Creek. It's not entirely untrue. But we want to point out that there's strong Creek. We can observe strong Creek among young men and older women as well. Okay, so it's not that young women are the only people that are creaking a lot. Okay. There's an affected age as well, so we see a change in apparent time. Creaky voice is most common at the ends of phrases, all right? And we find that younger speakers are using more phrase final creak than older speakers, okay? But younger speakers are also expanding the domain that creaky voice is used in, right? So the youngest speakers actually use creaky voice at the beginnings of phrases as well. And while older speakers categorically do not creak at the beginnings of phrases. Okay. The last thing we found was that speakers who earn their living off the land creak less than speakers who don't. All right, this was, you might be thinking, why the heck did you look at this factor? Well, while we were doing field work in these 3 sites, we found that this just struck us as something that seemed to be a salient distinction in the communities that we looked at. In all 3 of these communities, the land plays an important part in the local economies, right? So you get farming, you get, in all 3 of the sites, you get logging up north in Redding, you get oil in Bakersfield, and ranching well, here and Redding as well. And so we wondered to what extent this might influence the use of linguistic features, and it turns out for every linguistic feature every phonological linguistic feature that we've looked at so far, we found that this actually had an effect, including creak. In a 2010 paper, Yuasa makes a claim that creaky voice can index urbanity, and this finding that people who do not earn their living off the land use more creak seems to be consistent with that proposal. Okay, so that's kind of the big picture of what's going on with creak in California. What about, that's specific to California. I also want to review some studies that have drawn a link between the use of creaky voice and affect. Okay, and this is very different work. The work that I talked about was before was quantitative variationist work. This is more discourse analytic work. Collectively, these previous studies in discourse analysis argue that creaky voice indexes disengagement and maybe a negative affect. Okay, so to give you one example, Shanae Lee in a recent paper in Journal of Sociolinguistics showed that when speakers produce parenthetical speech, when they go off topic for maybe a clause in a sentence, they are more likely to be using creaky voice during that stretch of speech. She also argues, so basically we get a discourse distancing of the stretch of speech that's in creaky voice from the stretch of speech that isn't in creaky voice. And she argues that this distancing can indexically be used to, say, distance a speaker from their interlocutor, or maybe a speaker from the topic about which they're talking, okay? So this relates to, I think, a claim that Grivicic and Nylep made in 2004. They looked at just the discourse marker yeah when it's used in creaky voice, so yeah, all right? And what they argued was that it signals a passive recipiency. In other words, I heard what you just said, but I don't necessarily agree with you. I don't necessarily want to continue on with this line of discussion, but I hear what you said, okay? Lal Zimin makes a similar claim based on a recent analysis of one speaker who recounts a narrative about going home for the holidays. And this was, I guess the speaker has a fair amount of tension with his family. And in moments of the narrative when he's talking about that tension, those tenser moments with his family, he's using more creak at those periods of time, okay? So these are all qualitative approaches based on an analysis of language, okay? What about what the body's doing? That's where the lab data come in. So here's just a summary of the model. I'm not gonna go line by line through this. I just wanna draw, can you see the difference between red and black text in this? I don't know if it's very big. So the black text represents what I called earlier well-established linguistic and social factors. So these are things like phrase position has an effect, right? So you get more creaky voice towards the ends of phrases. This is something we've observed time and time again. Sex also has an effect. Women are creaking more than men in the corpus of lab data. So this is stuff that's consistent, that's completely consistent with the previous data that I talked about. The red lines here represent forms of embodiment that had a significant effect on their use of creak. And I'll talk about each of these in the later slides, so I'm not gonna go over them now. Okay, so moving on to the first one, there was an effect of smiling on creaky voice, okay? So this mosaic plot here shows the number of creaked and not creaked observations. So the creaky observations are in red, okay? This is the first chart I ever made with emoticons in it. I was very pleased to be able to do it. We've got the female speakers in the two boxes on the left, the male speakers on the right. And then we're looking according to whether or not they were smiling in the phrase during which the observation occurred. Okay, so what we see is that women are producing more creaky voice in phrases that they're not smiling in. Okay, this effect is not evident for the male speakers, right? So for the male speakers, we see about the same amount of creaky voice regardless of the smile. Okay, so that's one form of embodiment that seems to correlate with creaky voice. Another one is body movement. Okay, so we've got body movement here on the x-axis, and we see that as people move more, they creak less. Okay. Now, what I want to mention is this was an effect of body movement at the level of the phrase. Okay, so how much they were moving during the individual vowel in question didn't matter. Okay, it was how much they were moving during the phrase in which the vowel occurred. All right, and the last effect that we found isn't embodiment, but it's one of the interactional factors that there was a relation between creaky voice and comfort level. Okay, so as people feel more comfortable, they creak less. Okay, or another way of looking at it, people creak more in situations that they evaluated as less comfortable interactions. All right, so to summarize what we found, creaky voice is used more when speakers move less, okay, or people are more still when they're creaking, okay. When at least female speakers are not smiling, okay, and in situations where speakers report feeling less comfortable, okay. So these findings, which are not based on an analysis of the discourse, right? We're not using the linguistic data to make these observations, seem to point towards some of the same conclusions as the discourse analysis work, right? That creaky voice indexes disengagement or negative affect, but we're using completely different data. Okay. I also want to point out that by attending to the body, we're enriching the social analysis by moving beyond questions like how women and men are different from one another, right? If we connect the use of creaky voice to body movement and facial expression, we're now in a position to say something more interesting about why young women might be using creaky voice more than men, right? Perhaps it has something to do with the types of affective stances that young women are taking up. Maybe this should be part of the discussion, rather than essentializing that link between creaky voice and female gender identity. Okay, so that's the creaky voice work. I want to move on now to the lax front vowels. And again, I'll start with a description of what we know about the lax front vowels in California. So we've got the vowels kit, dressed, and trapped. I don't mean, by kit, I don't mean just the vowel I in kit. I mean all of the words that have that same lexical class. So of course I can't think of any right now. Help me out here. What are some words with kit? What? Kitten, is that, yeah. Skit. It doesn't have to end, it doesn't have to have a T at the end either. Skip would be an example, right? Not words like skim, because like nasals tend to have a raising property on vowels, so I excluded vowels that had nasals afterwards. Okay, what's happening though is that the front lax vowels are lowering and backing in California and most of the West as well, okay, and Canada. So kit would be pronounced something more like ket, right? Dress would be something like dress, and trap would be something like trap. Okay, I'm not a native speaker of California English, but I've lived here a while. I can do it reasonably well. Kennedy and Grama did a study based on red speech where they found that all three of these vowels were both lowering and retracting. Results have been slightly different in other work. So Cardoso et al., looking at Lauren Halloo's work in San Francisco, found that dress and trap, but not kit, were lowering, but not retracting. Okay. A slightly different finding was found by Janneke van Hofwegen, Teresa Pratt, and Annette D'Onofrio. They found that all three of the vowels were retracting but not lowering. Point of all of this is that there's movement in one of those two dimensions for these vowels across California. Some of these differences across studies might have to do with differences between coastal and Central Valley varieties of California. They could also have to do with different normalization methods used across the studies. So I don't want to read too much into the fact that the results are slightly different across the studies. Okay. That's the California vowel shift. These vowels, or vowel quality in general, has also been linked to affect. And this has been probably, the strongest proponent of this view has probably been Penny Eckert, who has argued that F1 and F2 are used to signal, a higher F1 and a higher F2 are used to signal niceness. Okay, so based on her field work with pre-adolescents in the San Jose area, she found that speakers were showing non-random patterns depending on the types of affective stances they were taking up in their interactions. So one speaker in particular, named, whose pseudonym is Colette, produced what Eckert calls a nice and a negative style. So I think she typically would produce this nice style, but over the course of Eckert's ethnographic observations, she got close enough to this young girl that she started to produce what Eckert is calling a more negative type of stance. Okay. This plot here is plotting F1 by F2 for the nice style, which is the dark squares, okay, versus the negative style, which is the triangles. And what she finds is that when Colette is producing, these are plots of the nucleus of nice. Okay, so when Colette is price, when Colette is producing the price vowel, in her nice style, she's using a higher F1, a lower vowel, okay, and a higher F2, which would be a fronter vowel. It's hard for me to do this. It'd be something like price. Price would sound nice, and price would sound negative. Notice I used my F0 too to signal the difference between those. I think these come as stylistic packages, and it's hard to do one of them independent of the other. There's nothing physiologically that's making them mix together, right? So my F0 is influenced by the rate at which my vocal folds are vibrating. My formant frequencies are influenced by the configuration of my supralaryngeal vocal tract, but they still go hand in hand regardless. Okay. Now, we have to think about the articulation of vowels when we're trying to understand at least the F2 patterning here, right? So the nice vowels are fronter or have a higher F2. One way of achieving a higher F2 would be to advance your tongue in the mouth, right? So if you're producing a back vowel, okay, or I should step back and say the F2 is a resonance of the front cavity of the vocal tract, okay? So if you're producing a back vowel, that front cavity is relatively long, okay? Let's say it's something like a flute, right? A flute is going to produce a pitch at a certain level. If you front the tongue, producing a front vowel, let's say, you're shortening the length of the vocal tract, okay? That's going to result in a higher resonating frequency. You turn the flute into a piccolo. That's one way of changing your F2 frequencies, okay? But you can change the length of the front cavity of the vocal tract also by smiling, right? So if you smile, your lips are going back, that's also going to shorten the length of the vocal tract. So when we get a higher F2, maybe it's because of something you're doing with your tongue, but it could also be due to something that you're doing with your lips, right? What did we find in the lab data that is actually looking at moments of time when people are smiling? Well, we found that smiling does have an effect, okay? Body movement did not have an effect at all, okay? So whereas there was a strong connection between the use of creaky voice and body movement, we did not find that for the vowel quality data, okay? Interestingly, so it seems like embodiment maybe has a slightly less strong effect, or a weaker effect on F2, but so did the social factor, right? Remember, sex had a significant effect on the use of creaky voice. It did not have a significant effect on the use of, on vowel quality here, okay? What did have a significant effect was smiling, okay? So here we've got the 3 different vowels, and all of them are higher. There's a higher F2 when there's a smiled vowel. So this is indicative of a fronter vowel. I plotted the 3 vowels separately just because they occupy very different spaces in the acoustical space. There was no interaction, so the magnitude of that difference wasn't really different according to vowels, even though the slope of those lines is not the same. Okay, moving on, I want to turn to the F1 results, or the lowering results, okay? So here again, body movement did not have a significant effect, but smiling did, okay? All of the stuff I said about the acoustics of smiling earlier with the tube models have to influence F2, not F1, okay? So smiling there should be no necessary effect of smiling on F1, okay? But we find that there is this correlation between when people are smiling and their F1s. I'll talk about what the pattern is in a second. Okay? But before I do that, I want to point out that, again, sex did not have an effect. So even though in these larger community studies, we typically find that women are more advanced in the sound changes than men, we're not finding that in these lab data, but we are finding effects of smiling. What are we finding for the F1 data? So here again, when people are smiling, they are producing a higher F1. A higher F1 means a lower vowel, okay? A lower vowel in the context of California is going to be a more shifted vowel, okay? So people are producing a more shifted vowel when they are smiling. Okay. So vowel quality, both F1 and F2, are affected by whether people are smiling. Sometimes that's due to physiological, automatic acoustic consequences of physiology, as in the case of F2. Sometimes it's due to other factors, as in the case of F1. Okay? But the data are consistent with what Eckert was claiming based on her ethnographic observations of Colette, that higher formant frequencies, both lower vowels and frontal vowels, index positive affect. Okay? But again, I want to emphasize that we're using completely different methods. These are quantitative methods that look at a different modality. Okay. All right, so I want to start wrapping up. To begin, I'll just start talking about some of the implications of the study for the quantitative analysis of variation. Body movement and facial expression constrain variation as strongly as well-established linguistic and social predictors. So if one of our goals as sociolinguistic variationists is to quantitatively model the variation that we observe, we need to be attending to these in order to produce these better models, right? Also though, advances in computer vision can be channeled into automating the coding of at least some forms of embodiment. So I think technology has enabled us to look at forms of embodiment. So we're improving our models, but we're able to do it because of advances in technology. So we've empirically established that there is a strong correlation between at least two forms of embodiment and two sociophonetic features. I think that's exciting and important in itself, but it leaves open the question of why there's a connection between the body and phonetic variation. And again, I think this has something to do with affect. In moments of situated interaction, right? So in these recordings that we're analyzing, people are relating to one another, right? They're signaling affective stances. And I think embodied resources and linguistic resources are both tools that we have at our disposal to do that, right? So we can say that forms of embodiment index affect. Linguistic resources similarly index affect. And that's why we get both of them correlate. That's why we get them correlating with one another, because they're both working in service of this need to relate to one another. Okay. I think one of the major upshots of looking at embodied affect is that it enriches our social analysis of variation. Right? We've built our theories of language change nearly exclusively around the social categories of sex, age, class, and ethnicity. Those are the big four for us. It actually gets us pretty far to take this view, but it's really an impoverished view of the social world. And it largely divorces language from the interactional contexts in which it's produced. In moments of situated use, we're orienting to one another, right? We're not so much displaying our identity categories, right? So when I produce a vowel, I'm not saying, I want you to know I'm a man by producing this vowel, right? I'm connecting with you in some way, and my vowel is going to be designed according to that. Now, I keep hammering home affect. Affective stance is notoriously difficult to operationalize in a quantitative paradigm. And I don't think that looking at affect in the way that I've done it today captures everything that a detailed analysis of affective stance could, right? I think if we do a more fine-grained interactional analysis of discourse, we can make some observations that I couldn't in this type of analysis. But it's more objective and it scales up easily to big data, right? I talked about 35 speakers, but once interactions are transcribed, we can look at a lot more, just using the same methods that we applied here. But I think more importantly for theoretical reasons, by looking at affect through the lens of embodiment, we can start to seriously think about why we use the linguistic features that we use, or why linguistic changes transpire the way that they do, right? So why do some changes get taken up? Why do others fall by the wayside? So to give you a taste of what I'm talking about, I want to consider a possible embodied explanation for why the front vowels might be lowering. Okay. What does an open mouth jaw setting look like? Well, here are two screen captures of characters from the Saturday Night Live parody, The Californians. Has anyone here seen that? Yeah, okay. So these are taken, these screen captures are taken from the middle of speech. It doesn't look like they're talking here, but I assure you that's where I took it from. So we've got Fred Armisen on the left here saying, "my eyes," the price vowel, with a very wide open mouth. Christina Applegate on the right here is saying the word husband. So this screen capture was taken in the middle of the strut vowel. Okay, a quite wide open mouth. There's also a facial expression that goes along with that open mouth jaw setting, but we don't need to go there. So clearly they're not opening their mouths in this way in order to produce authentic California vowels, right? They're embodying these characters, right? And lower vowels are an acoustic consequence of that embodiment, okay? In some work by Teresa Pratt and Annette D'Onofrio, they looked at Fred Armisen and Kristen Wiig, so that's not the speaker here. They were the two speakers that produced the most speech over the series of Californian skits that came out. Importantly, neither of these speakers produce Western varieties of American English natively, right? They're from the Northeast. But if you do an acoustic analysis of their vowels in the Californians, in many ways their vowels mimic the shape of the California vowel shift. It's not perfect mimicking, but there are striking similarities. Okay, and what Pratt and D'Onofrio are arguing is that it's not their linguistic virtuosity that enables them to accomplish the mimicry that they observe, but rather the way that they're physically performing the characters, right? So I want to ask, is there any reason to think that this open mouth jaw setting may be more prevalent than we think, right? Here we're talking about two characters from a very stylized, high performance type of Saturday Night Live skit. What if we look at the data from the Voices of California corpus, where I assure you the speakers are much less extreme? Well, if speakers are using this relatively stable jaw setting, right, that should have consequences for all of the vowels, not just the front lax vowels, this limited phonological class of vowels, right? So if this is really having an effect, we should expect to see an influence on other vowels as well. So I think we have that evidence. In some forthcoming work, Van Hofwegen, Pratt, and D'Onofrio looked at the front tense vowels, all right? So the front tense vowels are not supposed to be lowering in California, but what they find is that they're shifting in the same direction as the front lax vowels in California, okay? So the lax and front vowels are moving together. Well, if jaw setting is having an effect, it's not, it doesn't have insight into the phonological system, so it should also maybe be affecting the back vowels. The one that I've looked at is the goat vowel, okay? Generally, we talk about the goat vowel as fronting in California English, so like goat, so goat, okay? What I found is that there's, that F2 is predictive of F1. Okay, so F1, it turns out, excuse me, I said that backwards. F1 is predictive of F2. Okay, so F2 is fronting. Okay, the goat vowel is fronting at a parent time whereby younger speakers have a fronter O than older speakers. Okay, but young speakers also have a lower goat vowel than older. Young speakers also have a lower goat than older speakers. So they're producing, rather than saying goat with just a front but relatively still mid vowel, they're producing goat. Okay, so the lowering and the fronting are going hand in hand. Okay, so I think we obviously need to investigate this more thoroughly, but I think it's an intriguing possibility that something like a form of embodiment could be affecting language change, perhaps setting it into motion or maybe making it stick. Okay. Where is this project going? First of all, we're going to be looking at additional forms of embodiment to get closer to gestural annotation, right? So we've got Xbox Connect's set up in the lab. If you've ever used one, you know that it infers the skeletal representation of the game user, and it tracks actually each of the joints of that skeletal representation in a three-dimensional space, right? So you could use that if there's a particular type of gesture that you were interested in. There's a mathematical way of identifying that gesture, okay? So that's something that's a direction we hope to go in the future. In the present, Rob Voigt is looking at head tilt. Okay, so he finds that something like a head tilt is going to be much more gestural than the type of gross degree of body movement measures that we've been talking about. And he finds that head tilt also is predictive of a number of prosodic features like speech rate and F0. We could also look at things like mouth aperture, right? For smiling, we've looked just at plus or minus whether there's a smile or not in the phrase. The size of that smile might have an effect. Okay. Other future directions that we're going in. We want to look at additional variables. So we've looked at creaky voice today, but there are other types of non-creaky phonation that are interesting. Breathy voice, for example, would be one of them. There have been some proposals in the literature that breathy voice is used to signal a form of sexiness. It's hard to imagine that something like that could be produced without other bodily consequences. Okay? We could also look at other vowel qualities, right? So I've talked about the front lax vowels. What are the other vowels doing? We're lucky that English has so many, there's no shortage of things to consider there. We also want to look deeper at the interactional factors, right? So we talked a little bit about how comfort level influenced the use of creaky voice, but there are a number of other things we got people to rate the interactions on, and we want to look more closely at those data. We also want to look at a larger, more diverse sample. Part of that will include looking at the interactions between strangers, but also the sample that we talked about today is not so diverse in terms of speaker age. It's also not so diverse in terms of speaker ethnicity. So that's something we want to address in the future. There is some tentative evidence, though, that people from the northeast, and the west creak more than speakers from the Midwest and the South, right? And also some tentative evidence that people of color creak less than white speakers. Okay. So obviously we would want to confirm these trends based on a larger sample. So these are significant differences, but we don't trust the differences because we don't have enough representation across the groups in our sample. But we want to, if these tend to be actual patterns, we want to look at the possible relations between embodied affect and identity categories like race and region, right? Which I think will ultimately help us better understand correlations between creaky voice and gender, let's say. Okay. But anyway, the take-home point of all of this, I think, is that variationists should attend to embodiment. Right? Speakers use their bodies in non-random ways to structure linguistic variation in all interactions, including those recorded by sociolinguists. So up until today, all of the work that I've ever published has been based on audio recordings. I'm not saying that work is useless or becomes invalid, but I think that there's just a lot that we're missing out on by not attending to the body, and I hope that in the future we'll do that in order to enrich our theories.